welcome everybody that has joined us so far. So this webinar is all about transforming data management specifically for offshore wind companies. Myself and Darren will talk you through the various parts of what we do with our respective organisations and how that we come together as a partnership to help offshore wind companies. For those of you that don't know me, my name is Kevin Ward. I'm the Vice President for Petrosys and Terica in Europe and Africa. My background's in geology and petroleum geology, and I've been with Petrosys for about 11 years now. No, 12 years actually now, I think. So I've been here a little while. I know the company well, I know our software very well, and traditionally it's always been used for, or mainly used for oil and gas, for exploration and production. And more recently, we've been starting to do a lot more work with companies moving into different industries, things like CCS and of course offshore wind. And so we have our partners at ET Works that we've been doing some projects with recently, and they will together we've been using our respective skills and data management to help companies. And so we thought it would make sense to do a webinar today on what we actually do here at Petrosys and Terica and at ET Works. So Dan, I'll hand over to you if you want to introduce yourself, and then please go and share your slides and talk us through your stuff.
Yeah, so I'm Darren. I'm a Geoscience Services Manager at ET Works. I've been with the company for 17 years. Much like Kevin, my background's in geology. As ET Works, we're still very much a hands-on company. So I'm technical and operations manager effectively, and very much involved in terms of both consultancy and on-site work. As I said, I studied geology at university, and now I spend most of my time primarily focused on subsurface IT, especially seismic and then geoscience, and also in the kind of marine and oceanographic space. So I will now share my slides, if you will bear with me one moment. So yeah, a little introduction for ET Works, because I appreciate some of the people on the call are probably more familiar with Petrosys. This is us. This is what we try to do for our customers. Historically, we date back to 1993. We've been going 30 years, and we were primarily born out of the energy sector in upstream in terms of geophysical and geological data. Our big clients include the likes of PGS, CGG, Fugro, Shearwater, Dolphin on the kind of geophysical side, through to the British Geological Survey and into the kind of oil companies such as ExxonMobil, Shell, BP, Premier, etc. But we really became involved in renewables about over 10 years ago, I'd say, with Centrica in round 3 in the East Irish Sea. We did a lot of hands-on support and problem solving, and also a lot of strategic work, helping out with consultancy on the data management side around elements of PAS 55, which then became an ISO standard in offshore assets. And from there have kind of migrated into more support of offshore wind with the likes of both the operators and the marine acquisition companies. We work in a lot of other verticals as well, the NHS, multiple higher education bodies such as Robert Gordon University, College Gwent, Welsh Ambulance, the Science Museum, the Royal Opera House. If you visit these places, it's our IT stack. We advise and supply a lot of IT, but also help design data governance, data frameworks, and kind of get our hands dirty with day-to-day support. Yeah, so we are an IT provider. We're part of the Techies Go Green group in terms of our kind of ecological credentials. And our core competencies really are around kind of solution design and implementation, business IT transformation roadmaps. We deliver people, process, technology, strategy, and hopefully maximize benefits and minimize risks on this kind of journey. We develop IT strategies around consultancy and a kind of long-term architecture and next-gen IT in terms of VDI, data center solutions, cloud, etc. And we fill in the skills gap, provide technical and design professional services and data management resources. As you can see, that wedge on the kind of bottom right-hand side, Geoscience Services, is the area that I cover. So yeah, a bit of a kind of literary allusion, let's say. This is a quote from I've used multiple times in consultancy engagements. It's over 100 years old now, and it comes from Sherlock Holmes. But it is essentially data, data, data. I cannot make bricks without clay, or you could kind of say kind of ground models without seismic. data underpins the entire development lifecycle and the entire asset lifecycle, and managing that is critical. We can't make informed decisions without it, and the quicker and easier you guys as users have access to the data, the better. And the more you trust the data, the less legwork you have to do and the more time you can spend productively. When you build this at an enterprise level, you really want trust and data availability, but combined with full life cycle, so you can easily integrate past studies, build up correlations, analogies, etc. Equally, how do we preserve the data and the asset value over time? Projects get reopened, joint ventures created, assets might expand to phase 2, as we've seen with something like Rampion. And if new partners are being brought in, what data might you need to exchange and prepare for them? An analogy to that is, would you rather buy a used car with a full service history, MOT stamps and spare keys, or one without? And from a business perspective, crucially, which is going to sell for more money? Yeah, and then kind of on to this really, which is how much data is there and what are the data types? We'll come to the first question in a bit, but let's just look at the incoming data. Certainly this is not exhaustive, but we're trying to just really map data by project stage, and some areas are more intensive and more data heavy. There's big information management component to this in terms of document control, EDMS. This is often where energy companies, particularly those born out of power gen or distribution, struggle. Office documents are fine, but what about seismic? What about PAM data? What about your kind of environmental systems that you might put in place? Why is it important? These are the questions we've seen in the past. Why do you have third-party stakeholder and maybe legislative requirements around data preservation? You've got terabytes or petabytes of seismic data. It's static. What is it used for? That's the pushback from corporate IT. And why do we need to keep something like PAM data? Is essentially white noise, but there's legal requirements to keep it. And equally overlaying on that, you've got multiple stakeholders, the users of that data. They have come in at various project stages, but all these important groups need to either access data, have control of that data, or visibility of that data. And really, we were kind of looking at it from, is there a better way of managing this? This is what ET Works do on a kind of day-to-day basis in terms of support. We really help companies design strategy around data integration and enterprise level. That means data access, but also with control, with preservation, visibility, and findability. What we don't want to see is lost data sitting alone on kind of stranded USB hard drives or C drives on a laptop or a corner of a LAN. We want the correct users to be able to find and use that data. So we do data loading, we provide kind of technical assistance, records management, but we can also help design data strategies at a high level. That might be around the lifecycle management level, helping at the application portfolio level. Do you want Kingdom, or maybe you're looking at Petrel or something, but also you've got other systems in there like ArcGIS, like Fledermaus. Then you've got all your kind of project control systems like Maximo, Primavera. And this is where we help bridge the gap with these kind of companies and how we work with potentially with suppliers, partners, consultancies, MMT, RES, RPS, Wessex Archaeology, Crown Estates, etc. And then you've got other kind of third parties such as Greenpeace, local government, local farmers, landowners. How do you keep the data safe, and how do you potentially provide this access to these key members, either the team or third parties? And at the same time, we've got to be cognizant of the fact we want to make it efficient for the engineers, the geoscientists, for legal, commercial, operations, etc., to understand the kind of the big picture. Appreciating the size and scale and complexity of kind of data growth, the data challenge is going to be critical for the business success in the industry over the next few years. We have data feeds from the near surface, from the subsurface acquisition phase, from operations and maintenance, SCADA, PI, from production, etc., and through to everything from Met Ocean Buoys through to drone survey work. I borrowed an image there from a LinkedIn post that Fugro made. Their 2022 projects coming in are roughly about 100 terabytes on average. compared with 40 terabytes 2 years ago, 3 years ago in 2020. Their first offshore wind farm project from the late 90s, in comparison, collected 3 megabytes of data. That's well over 1 million times bigger. So you can kind of see the level we're going to now. And this slide really is just to kind of demonstrate the value of this, the commercial reality of it. They're high profile, high-end projects. This isn't quite rocket science, but it's not far off. We're talking multi-billion if you look at something like Dogger Bank, and they're only going to get bigger. It's an interesting question, and it's one I think worth asking internally about the value of this data and how you kind of look at securing it. And energy companies don't necessarily have that background in-house. So I think it's really important that you set up frameworks. It's foundation engineering in that sense, and it's not a million miles away from building up kind of data foundation as a structure. Yeah, and this kind of led us on to kind of work where we are designing these kind of data strategies. So what does that mean? Really improved user experience, hopefully, find data easier and faster through a single pane of glass interface, make better business decisions, access to missing data avoids costly mistakes, improve data confidence, plan for regional scale development, see correlations and analogies in the models, avoid data loss, removing these kind of issues of kind of hard data disk failures because it's actually in a secure location, enhance management visibility of projects at key decision points and gates, and faster, more accurate build times, better feed and kind of ground models through more complete integrated data assets, and improved and more efficient stakeholder, commercial partner, and regulatory kind of engagement. So this all led us into a position where we were designing full enterprise solutions as kind of IT data management ecosystems for offshore wind. Creating that kind of IT support framework that allowed users to access their data via kind of high-powered remote desktops anywhere, anytime. And we identified very early on in this that we need to have a kind of corporate data system to act as a repository, an archival system, and essentially a backbone, not just for the depth and size, but also the breadth and variation of this data. We needed something that we could integrate anything from the borehole data sets through to seismic, bathy, the subsurface, near surface, associated applications such as Kingdom, ArcGIS, through to also plugging into the new and up and coming standards such as OSDU. At the same time, we're integrating with document management systems, providing a spatial map interface that allowed data trust, search and auditing was kind of a key factor in this. So yeah, ET Works, we're primarily a managed service provider and integrator. We don't create our own software, and it's here that we kind of leverage our contacts and friends that we've worked with to identify suitable partners, suitable software. And this kind of discussion led us on to the interactions with Kevin and Jamie at Petrosys, and really what you're about to see in terms of kind of creating this kind of ecosystem and use of dbMap. And at that point, I will hand over to Kevin.
Nice one, Dan. Thank you very much. Just wanted to start just a very quick slide about Petrosys as a company. So we create geoscience and data management software for energy professionals. You might have heard of some of our technology, things like Petrosys Pro. We have, in terms of data management solutions, Interica OneView. Dan mentioned briefly some archiving capabilities there, and that's the software we use there. The software we're going to talk about today is dbMap. One thing just to point out is that we are owned by Constellation Software, which is a large Canadian software company, and through that we have a number of sister companies. So we do have other software companies working in offshore wind, such as our colleagues at the Sea Rock Group as well, and there'll be a link to some things that they're working on at the end as well. So we are branching out and having more experience and expertise in the offshore wind sector. So I just have a couple of slides. I wanted to focus more on the live demonstration, but I wanted to use this slide just to set the scene as to why you might consider a corporate database. And we have come up with 6 key data management challenges for offshore wind, and we'll look at why a corporate database can solve these challenges, these key challenges for you. So the first challenge that we see, particularly in offshore wind, we do also see it in oil and gas as well, but oil and gas companies tend to be around a little bit longer, and so their data management solutions are perhaps a bit more evolved, but we definitely see this in offshore wind companies, is that valuable data is stored on C drives and often just on USB sticks. And so if you imagine, if you put yourself into the position of somebody who's working on an offshore wind project and needs to find data, needs to find projects, needs to find documents, in terms of where you go to find that data, you're scrambling about on other people's C drives, you're trying to collate USB sticks to look at that data. A corporate database completely solves this accessibility option. You have easy access to valuable validated data. Essentially, you have a single source of truth. So when you need to find data, you have one place you can go and find it all. Now, the second challenge is, even if you do know where to find the data, you're unsure as to which data to trust. And some term that we often hear in this space is the term tribal knowledge, where if you know the right person at your company to go and ask, you might be able to find the right data. But if that person is not in the office that day, or that person perhaps leaves the company, suddenly you don't know which data to go and use and which to trust. And again, a corporate database allows you to find the vetted data, uses qualified data, and also can use quality metrics. And again, this is something that dbMap does, and we'll focus on this in a live demo, where you can actually see the quality of the data, not just that data exists. Third challenge is that metadata capture is highly variable. So two different teams that might be capturing, let's say, borehole information, might record that in a different way, might record different metadata for those boreholes. So if you need to quickly search across boreholes across a couple of projects, then there's inconsistency as to what you're actually finding when you do a search across the different data sets that are distributed across different servers. A corporate database can enforce consistency between those teams, make sure there's compulsory entries of particular metadata, which aids your searching. Challenge number 4 is version management challenges. So you might have found the data, you might know where to get it, but you don't know if you're using the latest version of the data. And perhaps your company spent a huge amount of money acquiring a new data or reprocessing data. And if you don't know that you're using the latest version of that data, then you might be using data that's outdated when there's better data sets available. Again, a corporate database can get around this challenge. Number 5 is there's no high-level ownership of the data. So if you're not using a corporate database, it's very difficult to do analytics on the state of your data. And this is where our partners at ET Works become invaluable. Their service people can, as Darren mentioned, some of the services that they offer, they can track the data quality and they can improve that data quality through time. And again, a corporate database just makes this process possible. And number 6 is a lack of security. So you may have data in different sources, but nobody has an ownership of it. And at best, you don't know who's responsible for managing that data. At worst, people might be able to access data they shouldn't, and perhaps even delete data that's valuable as well. So centrally managed corporate database allows you to set security and permissions so that you're only seeing the data you need to see, and it cannot be accidentally deleted. Now I'm going to go through the next 2 slides in about 30 seconds. I just wanted to have them on the screen so you can come back in the recording if you need to. This is essentially how dbMap is structured. We have a central, robust, gold standard database where all of the data is organised and managed. It's accessed through a web interface, and it's the web interface that I'll show you today. So a nice modern, nice easy to use interface. We can push and pull data in and out of the database, either using our own exchange capabilities, which I'll show you on the next slide, as well as GIS links as well. We can also bring in links to unstructured data, so documents, reports, files, and we can tie those to the data that's within the database as well. And finally, we have a good, strong service team behind us, which can provide services to set up the software. And obviously, combined with our partners at ET Works, we have a breadth of knowledge and experience in data management services. And then finally, this slide just to show you that we do write our own connections to data. So ET Works also have a lot of experience of being able to push and pull data in and out of databases and into projects. But we do also have our own connectors to things like Betrayal, Kingdom, OSDU, for example. So if you need to push and pull data between the database and sources to populate projects, we have that capability. Okay, so that's enough of the slides. Let me just jump to the live system that I have in the background. So I have 10 value propositions that I'm going to hopefully cover in the next 5 to 10 minutes. And so this is the system, this is the web interface to access the system. Excuse me. And the first thing you can see is that we're logged into the system with a particular username. So the first value proposition is that we have a secure database, we can log into it, and we can assign different permissions and privileges to each user who does log in. Now, as a geotechnical person, the way that I'm going to want to access the data is typically in a spatial form. That's typically how geoscientists like to access the data. And so we do that by going to the map interface. And if I do that, you can see that the data I'm using here is from an undeveloped wind farm project called Navitas. And this is all publicly available data that we've brought into the system just to show you what it would look like in here. And we can click on some wells that we have displayed here, and I can click on each well, and then I can see extra additional information about the wells from the database. So some general information, depths, locations, dates, some other information. As much as little metadata is enforced by my company, essentially. We also have some downhole information, which I'll come back to in a few moments. So you can see that if I wanted to click on these wells and instantly access the information from the cores, I could click on that link there, and it would take me into the deeper part of the database where I can start to access that information. Now I'm going to jump back out of that. I'm going to come back to this deeper part a little later on. And you can see we also have some data quality metrics for the data in there. And again, I'm going to come back to that in a few moments' time. But the real value proposition here is that as a geoscientist, I want to access the data spatially, and we have a fully spatialized database that allows you to do that. I'm going to toggle on some other data that you might want to use. In this case, we have some seismic lines, and I'll zoom into these seismic lines, and I'll just click on one of those there. And again, you can see we've got some high-level information about the seismic lines and the acquisitions and the data quality. But if I click on this tab here, it takes me into the records management part of the database, which is all about managing unstructured data. And I would be able to see all of my unstructured files associated with these seismic lines. So the third value proposition is that unstructured files, whether it be reports, PowerPoint presentations, PDFs, TIFF images, for example, all of those unstructured data can be associated with structured data like seismic and like boreholes. In this case, the only unstructured file I've got here is a segue file. And just to show you very quickly, because this database is tuned for energy professional needs, we can read bespoke data types like segue files. So you'll see down here we have a seismic viewer. So I can click on that, and a viewer built into the database can view that seismic segue file there. So I just rotate the screen a little bit. You can see we've got the milliseconds reported here. We can zoom in and out and pan up this section here. We can also view header information. And I could spend 5-10 minutes going around here showing you some of the tools, but I just wanted to show you that does exist. And the value proposition there really is that before you populate a project with your segue data, you can view it from the corporate database, make sure it's the right data you're looking for before you go in and populate a project with it. There's then a bunch of other data that we can display in this map view. I'll just toggle on some just so you get an idea of some of the things that we can display. So in this case, we have a seabed video survey. So even if it's not a specific data type that we might have used in previous years for oil and gas exploration, we can incorporate that into our database. It's very configurable and fine-tuned for offshore wind needs. And so if I click on one of these here, for example, this is this seabed video is known as number 74. If I go into the see more information option here, again, I can then dig in and drill a little bit deeper into what we have stored for this point data set. So I can go in and look at the wells or the seismic associated with it. And I can also attach data as well. So for example, in this case, I've attached the actual survey that was associated with that, and I can view that video live from here as well. I should just point out this video actually isn't from this data set, but I just grabbed that off the internet so that I could show you that we can attach videos to these point data sets if that was something you wanted to do. So again, thinking back to the analogy of everything on C drives and USB sticks, I don't now need to go and spend a huge amount of time trying to find that data elsewhere. I can just find it all from within this single source of truth. And I can toggle on lots of other things, so unexploded ordnance, wrecks, bathymetry, contours, whatever GIS data my company needs me to store against this project, and we can store it all inside of the database. Okay, so yeah, fifth value proposition is we can handle any spatial data really that you need. It's fully adaptable to wind energy needs. What I'm going to do now is just jump into the Wells tab and look at some of the more advanced things we can do with the data types. Now, in this case, we call this point data set wells. For wind energy, offshore wind energy, we've probably referred to these things as boreholes more than wells, but it's just that the software calls them wells. And you can see we have 918 boreholes or wells associated with this database, and we can easily filter through the sources. So if I filter for the Crown Estate, for example, I can see all of the boreholes for the Navitas project. So very easy to use, and we can also do more advanced queries as well. So value proposition 6, very easy to use modern interface. Now, if I click on one of these wells here, I'm going to click on borehole 5. And again, we can look at more information here. We can also drill down and look at a lot more deeper information underneath, such as cores or surveys that have been associated here. I'm just going to click on data quality and show you that within the database, we show a visual representation of confidence and quality. And this is really important because even though you have the data in the database, it might not have been QC'd, might not have been checked, might not have passed some decision gates. And so it's very difficult to trust that data. What we do in the system is we store confidence and quality. Now, confidence is a subjective entry, and so if that piece of data has passed a decision gate, and if my username has the relevant permissions, I can change the confidence on that piece of data to something else. So let's say it's high quality, and we've maybe done some sort of internal assessment, and that one's passed. And so now that I've got the relevant permissions, we can change that, and we can now see very easily in this visual representation that this piece of data has passed some sort of decision gate and it's trustworthy. Now, the right-hand hemisphere is all about quality, and that's an objective metric that we use, and we build in some rules. These rules are configurable, so they can be suited to your needs, and we can see that it's passed the medium quality rules. So it's got a well name that's not like any other well name, and it has a valid coordinate reference system. Therefore, this piece of data is medium quality. It's passed some high-level quality rules, but it's not passed this one here. It doesn't have a known status. So again, as a data manager or someone with the relevant permissions, I could come to this data set now, and either on an individual basis or using some scripting to do this on a multiple basis, I can change the current status of this well. Let's say this was let's say it was an active drilling borehole. Click OK. And you can see this is now past the high quality rule as well. So very easy to have these visual cues, and they allow you to trust the data that you're using. So value proposition 7 is that it's an extensible framework. We can fine-tune things to when energy needs. And value proposition 8 is that we capture data confidence and quality, showing that visual representation of what data you can trust and what data you might want to go and have QC'd before you actually use it. Now I'm going to use a different well here, so I'm going to clear all of this data. I just wanted to show you that we also have a well log viewer built into the system, which might not be as relevant for offshore wind, but I just want to show you that it's available if you are recording logs for any boreholes. So this data here, this Stratford 1 well, does have a lot more information associated with it. So you can see down the bottom here, lots of stuff in bold, showing that we have lots of data tables filled in for this borehole. And if I click on the downhole diagram, you'll see we have lots of tops, casings, cores, well test, perforation. So again, the more data types you support for each borehole, the more that we can support here. I'll just click on well logs and show you that we have some logs associated with this with this well here, and if I click on the well log viewer, we'll then see that we can bring up this log viewer, toggle on some surveys, and again it's just showing that we can use this data here to QC the data, make sure it's the right data we're looking for before we actually go ahead and export this data into our working project that we might want to use. So just do a quick cross plot to show you that's also possible as well. So value proposition 9, same as the seismic viewer, it's a very technical database, so any sort of viewers that you might expect to use in a technical capacity we've built into the application. And the very final value proposition to show you is just about our unstructured data. So I just wanted to show you that that we can associate files with boreholes or with seismic. Now, I know this system well, so I know that I'm looking for this thing called RM catalog. So we have 104 files associated with this well here, but we can also access our files from the records management tab here. So if I click on that and click on search, I will see that I have access to 152,000 files within here. And again, I can filter for things very easily. So if I'm looking for the UK Crown Estate for my Offshore Wind project, I can file for that there. And then I can also just filter for names. I might just type in Barton as the thing I'm looking for. And if I click on this KML file, which is a Google Earth file, you can see I can download it here, but I can't do any viewing. So if I wanted to use that file, I can download it from here and then view it in Google Earth. But if it is a file that we do support, so things like well logs, things like SegWi, things like TIFF images, there's also a preview or a viewer button. And so from within the database, I can click on that, and you can see I can view this TIFF image directly within here. Again, going back to that initial concept, it saves me going to separate C drives, saves me spending a huge amount of time gathering all that data and trying to make sure that I'm using the latest versions of the data. I know I can trust this, and I know I can access it instantly from within dbMap. It's a huge time saver, and I can spend my time doing more productive things. So thank you very much for listening to that that presentation and the live demo. I'm just going to throw up this last slide here as well. So in a minute, I'll break and I'll ask Ashley if we have any questions in the Q&A log. But I think Ashley's also posted in some other links. So there's a link to a website that we've started recently called offshorewindsoftware.com, and that was started by our colleagues over at Sea Rock Group, who, as I say, we're owned by the same parent company, so we're sister companies. We've done a recent CCS white paper. That was a project we did with ET Works, and that link should be available as well. And I know it's for carbon capture, it's not offshore wind, but just to show you how dbMap can be used for data management. There's also a LinkedIn group that we've started recently, or Sea Rock has started recently, for offshore wind software. So go and check that out, follow that group and see some posts on there. And hopefully you'll also have our email addresses if you want to reach out to us separately. But thanks again for attending, and hope you all enjoy the rest of your day.
Thanks, Kevin. Thanks all.
Thank you.